All right, so we're going to solve this problem, this limit problem. We have that the limit as x approaches 2, or we're trying to solve the limit as x approaches 2 of x squared minus 4 all over x minus 2. We see that because x approaches 2 and we have x minus 2 in the denominator, we have a discontinuity at our limit value. This is because obviously, the denominator equals 0, so it's undefined. This means that we have to perform some sort of algebra to get that discontinuity out of the denominator in order to find our limit. If we can't do this, then the limit does not exist. So essentially what we're looking for is some way to cancel a term in the top with a term in the bottom, or some sort of algebraic manipulation. In this case, what we're going to do is we're going to describe the limit as x approaches 2 of x squared minus 4 all over x minus 2. We know that this component right here can be factored because it's a perfect square. So we can rewrite it as x times x. The reason we know that this is the case, that they're just x values of coefficient 1 here, is because when they multiply together, they're going to give us an x squared, which is what we have. Now we just need to find what two numbers add to 4, or sorry, what two numbers add to 0, right? Because we have a 0 value on the x term here, right? And what numbers multiply to give us negative 4? Well, of course, in this case, those would be negative 2 and positive 2. The reason for this is that when we multiply this through, we're going to get x squared, then 2x, then negative 2x, and then finally negative 4. You know that this is going to be the case, that it's going to be in this form when you have a perfect square. So we can rewrite this limit equation as the limit, as x approaches 2 of x minus 2 times x plus 2 all over x minus 2. Now this is great because this means that these two terms, they cancel, and what we're left with is, I should put this down here, is limit as x approaches 2 of simply x plus 2. Now, what is the limit of x plus 2? The limit of x approaches 2 of x plus 2. This is just going to be 4, right? Because we can just plug in 2 into our x value. So that's the equation, or that's the solution. So we're going to use the limit definition of the derivative to determine the derivative of f of x equals 4x squared minus 6x. So first of all, we need to determine what the limit definition of the derivative is. We know that this is, and this is just something you'll have to memorize, f prime of x is equal to the limit as h approaches 0, that's a 0, of f of x plus h minus f of x all over h. So basically, this is one of the nicer things about calculus. All you have to do in this case is just plug in those values, right? So we can rewrite this equation, or rewrite this limit as the limit as h approaches 0 of, again, that is a 0, of, let's see, I'm using square brackets here. So 4x plus h times x plus h. This is just x plus h squared. I'm trying to conserve space a little bit here. Minus 6x plus h. And that's going to be minus, this is a square bracket here, so minus 4x squared minus 6x. And that's going to be over h. Okay, we're going to perform a bunch of algebra here just to, get this into a form we can really kind of work with. So as h goes to 0, let's see, let's do some algebra. This is going to be 4 times x squared plus 2xh plus this is going to be multiplied, by the way, plus h squared minus 6x minus 6h. And then we're going to wrap these in parentheses. I know this gets confusing. Minus 4x squared plus 6x. It's all going to be over in h. Okay, so I've just deleted a bunch of terms up there so that we can hopefully do this easier. So we're just going to go through and distribute. So this will be 4x squared plus 8x, 8xh. And then this will be plus 4h squared minus 6x minus 6h. Sorry, 6h. Minus 4x squared plus 6x. So now we should have various terms cancel. So we see that we have a 4x squared here and a negative 4x over here, negative 4x squared over here, I mean. We also have a negative 6x and a 6x, and this will all be over h. So now we have limit, as h goes to 0, of 8xh plus 4h squared minus 6h all over h. We can see that terms cancel. The h cancels with the h in all of these, leaving us with the limit as h goes to 0 of 8x plus 4h minus 6, which when h goes to 0 can just substitute it in here and we get 0, leaving us finally with the derivative of f of x is equal to 8x minus 6. Okay, so now for the third question, we want to determine the antiderivative of f prime of x equals 6x squared plus 4x. So basically, we want to find the function f of x for which the derivative is equal to this, 6x squared plus 4x. So we're essentially looking for, let's start with the first component, 6x squared. We know that when we take a derivative, we drop down the power and multiply it by the front, right? So we know here that if we have 2x cubed, when we take the derivative of 2x cubed, we're going to get 6x squared, right? Because you drop down the exponent and multiply it by the first coefficient. Likewise, for the second component, we can see that if we have 2x squared, when we take the derivative of this, we're going to get 4x. Now, the last tricky part is that we need to keep in mind that really we can have any constant in front here, right? Because when you take the derivative of a constant, you get 0. So our final answer is going to be 2x cubed plus 2x squared plus c.